All right, this video is going to look at water use specifically. It's another element of the impact of food. It's one of the components of the food, the footprint of food, ecological footprint of food. So, as we've seen this image before, freshwater use actually accounts for 70% at a global level of freshwater withdrawals. So basically what a freshwater withdrawal is of the freshwater that we have available to us, it's what we take out and use. So of what we take out and use of our freshwater supply, 70% of it on a global average goes into agriculture. And we can think of this as consumptive use. All right, it's water that's not, it's kind of permanently withdrawn from its source, and it's no longer available to be used because it's either evaporated, been transpired by plants, so plants will use it and then evaporate it into the atmosphere. It's been incorporated into the body of the crop or the animals or the people. So it's otherwise been used for immediate use. All right, so think of this as consumptive use. Water is a renewable resource, but it is kind of in a somewhat limited way. Right. When we're talking about the water, fresh water we're talking about a very small proportion of the Earth's fresh water. So we know we've got, here on the left, we've got most of the water on Earth, most of it's in the ocean, and of that little bit in the groundwater, or in the fresh water, we end up with 30% of it being groundwater, another almost 70% of it being frozen. So then we get this other little piece here that's surface water, and that's what's over here on the far right. The surface water, some of it's snow and ice, lakes, rivers, swamps, things like that. So when we're talking about water for agriculture, we are talking about groundwater and sort of this surface water part. Okay. So the water that we have available to us from the Earth is really, really a tiny fraction of the Earth's available water. So well less than 1%. There we go. Okay. And when we're talking about, so again, surface water is water that's where the water table is basically above the surface of the land. So water we look out and we see, the lake, the stream, the river. But that's always connected to groundwater underneath the land as well. So that groundwater can be pretty close to the surface when the water table is close to the surface, and then certainly deep into aquifers as well. So when that water is well below the surface of the Earth as well. It's not always equally accessible to us. Surface water is obviously more accessible to us, and to get groundwater we have to drill down into it if we're not in a place where the water table is intersecting the surface of the land. Right? So what do we do with all this 70% of these water extractions that we're taking? We mostly use it in agriculture. So again, here's our kind of and this is slightly older data, but this is still a trend. Most of it's going into agriculture at a global scale, and then it's used in industry, and then there's municipal use, and that includes domestic use. So the vast majority of it is agricultural use. And we've seen the water use go way up in the 20th century, so has population, right? And so by having so many more people on the planet, we need that much more food, hence we need that much more agriculture, hence we need that much more water to be used in agriculture. So our overall trend is increasing water use, and again, think of that as a consumptive use. Water is a renewable resource, sort of, but there is a finite amount, and it does not renew at the rate at which we're using it, right? That's an important piece of this puzzle, is that it does eventually, when plants evaporate, when water evaporates or plants transpire water, it'll go into the atmosphere. Eventually it'll precipitate back down and maybe be usable for us again, but maybe not if it lands in the ocean. So it's a renewable resource, but think of it as a finite consumptive resource. What we're doing with it, so if we think back about this, 70% globally we use in agriculture, but it's not the same by kind of area. When you think about it, and that largely relates to development as well. So Europe uses a relatively small proportion of its water withdrawals in agriculture. much larger proportion in industry. The same thing for the United States. I'll show you some United States numbers here in a second. Developing world, less economically developed countries tend to use a higher proportion of their water for agricultural purposes. And that just goes along with, in a less economically developed country, more people are farming. So there are more farmers, and a higher proportion of their GDP is sort of subsistence farming. So they're and because that's fairly diversified, there's a fair amount of water use there. In the United States, we are a pretty, economically developed country, and so we only use about a little over 30% of our freshwater withdrawals in agriculture. The bulk of ours goes into power generation, which shouldn't be surprising. We're a power-hungry country. We use kind of the most energy of any country in the world, so most of our water use does go into that. Right? So slightly different proportions of water use depending on kind of your economic situation as a country. Right? So what do we do with water for agriculture? We can either feed it directly to livestock, so watering your livestock, or irrigate with it. And primarily what we do with it is irrigate. We irrigate crops. And so if you've flown over the middle of the country and you had a clear day and you could look out over, a lot of the prairies and flat, kind of flatter agricultural areas in the middle of the country, you'll see something like this. This is a irrigation wheel. Basically, there's a pivot at the middle, and there's a wand that will go out in a radius, and it will circle all the way around. So it's a way to irrigate a circle with the kind of the least amount of infrastructure. So you'll see these circles in a bright green and otherwise kind of gray or dirt colored land around them. So this is an agricultural system that really depends very heavily on irrigation. So it's mostly for irrigation. And this is this is from the USGS, the United States Geological Service, phenomenal resource in understanding hydrology and geology in this country. And so here we can really see where, move me out of the way a little bit there, where the water's going. So we've got surface water and groundwater that are used. And if we think about we've got agricultural uses, we've got irrigation here, we've got livestock, we could kind of include aquaculture in there, but really thinking about livestock and irrigation, vast majority, highest proportion again for irrigation. We don't necessarily all irrigate equally. We've got not the same climate all over the place in the country. Right? So here in the Northeast, we're pretty lucky. We don't have a huge, we do a fair amount of agriculture here, but we also get a fair amount of rain and precipitation. So really all throughout the eastern part of the United States, we have a fair amount of precip. And so we don't have to pull as much water out of the groundwater sources or surface water sources to be doing irrigation. If you look at the pattern here, the western United States tends to be drier, and we need to have a lot more irrigation there to make that land agriculturally as productive. Now, they have some other things going for them. They've got really great soils. We have, particularly in the Northeast, tend to have pretty crummy soils as a result of the recent glaciation. So, there are pros and cons. The glaciers didn't come this far down into the Great Plains, so they have incredible soils there. We don't have that. And this is sort of a classic view, thinking about sort of the humidity or aridness of the United States. Roughly organized around the 100th meridian, so to the east of that, relatively humid, basically enough water to really support forests. Right? And to the west of the 100th meridian, except at higher elevations in the intermountain west, it's a much more dry, much more arid, and not really enough water to support large forest stands, except again at elevation where you get a precipitation effect from elevation. So mostly grassland in much of this area as a result. And this is an area where you see, again, the highest irrigation rates. So we need to pull a lot of water, make a lot of water available for irrigation in these areas as a result of that. So what does that look like? Again, we saw the crop circle earlier. This is an image of agricultural activity right outside Phoenix, Arizona. So down here, where it's very, very dry. It's very hot. They get a lot of sun, and they've got a lot of warmth, so they're not limited in that sense. But what are they limited by? Water. So you basically have a couple of options when you want to raise crops in an area like that. You can pull water from surface sources. So in this case, a lot of crops in the desert Southwest are irrigated using water from the Colorado River, to the point where many years the Colorado River does not actually reach the ocean. Usually it drains down through here, and it actually comes down into Baja, not the Gulf of Mexico, the Gulf of California. But many years no water actually gets here because it all gets used in irrigation in the desert Southwest. Irrigating crops in the desert, right? Which is kind of crazy talk. And then you can also pull water out of groundwater sources, so aquifers, so that you can drill down, you can drill wells and drill water out that way. And so again, thinking of water as a consumptive, consumptive use of water for agriculture, when we're pulling water out of aquifers, yes, aquifers will eventually replenish themselves. There's always a sort of constant trickle back into an aquifer, a repletion of the aquifer, but when we pump more water out than is able to go, than the rate at which it is recharged, we get what's called aquifer depletion. So all of southern Arizona, for example, is in a state of aquifer depletion. So the hotter, the warmer the color here on the chart, that's an indication of how much depletion is going on with the groundwater. So we see a lot of it in a lot of the major agricultural areas. So that idea of actually growing crops in the desert. So this is the Central Valley of California, again, over here. And again, we're seeing pretty significant groundwater depletion there, to the point where you get something called land subsidence, where the land, like the surface of land, actually sinks. It gets lower. It can be measurably lower. The entire Central Valley of Central California is actually subsided, I think, on the order of feet from the water extraction from the aquifer down below it. So this is, makes little earthquakes and things like that. It's kind of crazy. So aquifer depletion is one sort of thing that we can be aware of when we're thinking about extractive use of water for agriculture. So we overexploit this non-renewable resource. That's one way we can do it. Here in the United States, or here in Maine, in the winter you go to the grocery store and you're buying vegetables. Where are they grown? They're grown outside of Phoenix. They're grown in Southern California. And what we're doing then is we're actually importing water. So when you eat vegetables that are grown somewhere else, you're importing water from this place. So we have plenty of water here, but we are having a net importation of water from the desert where those crops are grown, because it's pumped out of the ground here, it fuels crops here, and then they cut the lettuce and pick the tomatoes and ship them to Maine, and that water that makes up those vegetables initiated in the groundwater of these depleted aquifers. So although local food may not have a whole lot of a huge impact on your carbon footprint, it has a big impact on your water footprint, because when you're shipping food around the country, you're shipping basically embodied water. And on that note, footprints. Different food items have different water footprints. And you can think about it per kilogram of food, per calorie, per protein, so macronutrient, or even per fat. Right? And we're about to run out of time, so I want to just blow through these a little bit quickly. So unsurprisingly, our world in data, we do have some more numbers here by, again, food sector. So beef, unsurprisingly, again, we are talking about, has super high footprints when it comes to water. If we look at, this is sort of a square meter version of footprint. But if we go to, we can actually start to look literally at liters of water per calorie produced. So again, our beef, our goats, or sheep, Higher up on they're eating plants, so there's inherent losses, there's inherent inefficiencies in that system, and the meat is these animals are concentrating those resources